Hey guys, so I know some of you missed class today. We spent the time going over all of the review packet that I gave you that's due later tonight. This is Tuesday, October the 20th. And basically what I wanted to do is, for those of you that weren't able to be there, I just wanted to go through and work out some of the problems for you in a video format. So it's going to be a little bit different, but if you watch this, you should be able to at least work the problems out. All right, so for part 2.1 quadratics, you're given the equation. Reminder that the vertex of the parabola, the x value is the opposite of b over 2a. Well, if that's the case, and the equation that you were given, you would put in negative 0.7 divided by 2 times negative 0.01, and if you work that out, that ends up being 35. Now again, that's just the x value of the parabola, or the vertex, that's not the y point. To get the y value, you plug the 35 back in, so you would have negative 0.01 times 35 squared plus 0.7 times 35 plus 6.1, which gives you an x value of 18.35. So the vertex of this parabola is 35, 18.35. So in other words, the 35 tells you that it's going to be 35 feet horizontal before it reaches its highest height, which happens to be 18.35 feet. So the significance of the vertex, it gives us the highest or lowest point depending upon the function. Okay. Now, if you look at the first box, it says under the description, it asks how high does the shot put go. Well, you just answered that. The height of the shot put is going to be 18.35 feet. That is its max, because that is part of the vertex, and that's the y value of the vertex. So you would put 18.35 feet in there. Now, in order to figure out how far does the shot put go, again, the shot put's going to stop when it hits the ground. Okay, that's the distance that it gets measured. So that's what we want to do. So the ground level is 0. So we're going to do 0 equals negative 0.01 x squared plus 0.7x plus 6.1. Now, you can try all day to factor that, but that's not going to work very well, so we need to use our quadratic formula. That's the best way to go about getting the values here. So when we plug in everything into the quadratic formula, we're going to end up with negative 0.7 plus or minus 0.8567. If you don't get those four numbers, it's a long decimal, but if you don't get those four numbers, you did something wrong with your radical. And it's going to get divided by negative 0.02. Now you've got to be careful, okay? Because we don't want a negative distance. So if you think about it, if I do negative 0.7 plus 0.8567, that's going to be positive, and then I'm going to divide by a negative. That's not what I want. So I'm just going to worry about the negative. So if I do negative 0.7 minus 0.8567 and divide it by negative 0.02, I end up coming up with 77.835 feet. Okay. Now, as far as the table is just for you if you want to put in more values. One other value that you can easily find is the y-intercept by putting in 0 for x, and that should be clearly going to be 6.1. Okay, so then the graph there is basically for you to go ahead and just graph. The best way to do the bottoms, and this is all going to be a quadrant 1 problem. So I did 20, 40, 60, and 80 across the bottom. And I counted by ones on the side, so this should have been 5, 10, 15, and 20. I know that at 0 I'm at 6.1, and at 35 I am at 18 point something, and then over here at 77 feet I'm down at 0, and there is my graph. Now again, that's not using the graph paper, that's just a quick sketch here on my high quality little iPad. So I expect a little bit better than that, a little bit more accuracy than that. Don't forget to label your axes with your numbers and things like that in units. Okay, and the understanding question, guys, that function is in vertex form. And the reason it's in vertex form is because the vertex is staring you in the face. The vertex is 5, 4, and we talked about this when we talked about transformations. And this is vertex form. So that's how you should be able to find it rather easily. Okay? And that's the end of 2.1. Okay, 2.2, polynomial functions. From here on out, no calculators allowed. You were allowed to use a calculator for the quadratic part because you needed it, but now at this point you shouldn't need it anymore. Okay, so for this polynomial, you have -2. I'm not writing a lot down because, guys, you have these papers. You should have printed them out or at least be looking at them. So we have -2 times x plus 2 times, okay, let's try this again, -2 times x plus 2 times x minus 2 squared. Okay, so first off, we want to know the end behavior. Using the x approaches infinity, what does f of x approach notation. In order to find polynomial end behavior, you need to know two things. You need to know the degree, whether it's odd or even, and you need to know what the leading coefficient is, if it's positive or negative. So you should be able to tell me that this is a degree 3 polynomial, okay, and that the leading coefficient is negative. So what does that mean? Well, if you remember from class, in this type of notation we have x as x approaches infinity. What does f of x do? And then as x approaches negative infinity, what does f of x do? This is the one, if I have an odd degree, these two should be, the f of x's should be different. And if the leading coefficient is negative, then that means that I should have negative infinity and positive infinity. And that's just something that the more you do it, the easier it gets. Now find the zeros of this function. The zeros should be really easy, guys. We have 2 and we have -2. Okay? So we have x equals 2. That is a multiplicity of 2. Because of the square right here. We see this 2 times. And we have x equals -2, and that has just a multiplicity of 1. Okay. Y-intercept, just plug in 0 to your function. So you have -2 times 2 times 4, which ends up being -16. Symmetry, I always leave until after I do the graph, just because it's easier to look and see on the graph if there's symmetry or not. I can tell you right now there isn't any, but that's beside the point. And then the maximum number of turning points, that's just simply the degree minus 1. So the degree of this polynomial is 3, minus 1 is 2, so we have 2 turning points max. Okay, so now we're down to the graph. We need to go ahead and put our graph. On your graph paper, I numbered by 4s going on the y-axis, and -4, -8, -12, -16, and then these were by 2s, or actually by 1s, So this was 2, 4, -2, -4. Okay. With that being said, I had a 0 at -2, and a 0 at 2. I have a y-intercept way down here at -16. According to my end values, I'm coming down through. I'm crossing at that -16. I'm bouncing off -2, or I'm bouncing off +2, and I'm going back down. I bounce off the +2 because that has a multiplicity of 2. Anything that has a multiplicity of an even multiplicity bounces off the axis at that point. Okay, and it's just, again, this is supposed to be a review, guys. All right, so if you're having questions about this, please see me during office hours. I know there's not a lot on Wednesday, but you know, your test isn't due until Friday, and I can certainly answer questions for you on Thursday. Okay, so now let's look at number 2. We have -5x squared minus x cubed. Again, the degree is 3, and the leading coefficient is negative. So this is going to be just like the last problem. You're going to have x as x approaches infinity. F of x approaches -infinity. And as x approaches -infinity, f of x is going to actually approach +infinity. Okay, the zeros and the multiplicity, well, we need to factor this. So we have 0 equals -5x squared minus x cubed. So I'm going to pull out the -x squared, and that gives me 5 plus x. I'm just going to rewrite that as x plus 5 because it's going to be the same thing. All right, so I now have -x squared equals 0, and I have x plus 5 equals 0. So I now have x equals plus or minus 0. Took the square root of both sides, and remember, whenever you take the square root, you have both positive and negative roots, and I have x equals -5. So there's my two zeros. X plus or minus 0 is a multiplicity of 2, and x equals -5 has a multiplicity of 1. Okay. Forgot to mention on the last one, there is no symmetry. Once you take a look at the graph, you can see it does not flip over the x-axis or y-axis easily, and it does not rotate it around 0, the origin, easily to get you exactly back where you were. Okay. My y-intercept, this one's easy, guys. It's going to be 0, 0. Here's my y-intercept. This one also has no symmetry, as you'll see when we graph it. Turning points again, 2 turning points. Okay, so let's see what this graph looks like. All right, so we have 2 points. We have -5 and we have 0, 0. According to our end behavior, it comes down like this. Now it's going to have to curve somewhere down here and come back up and touch 0, bounce off, and come back down. You know, this is where you have to really realize that that multiplicity of 2 does make a difference. It's going to bounce. You know, you can actually mathematically figure out this point, but it's not really worth it. Okay, you would probably need a calculator for it anyway. And as you can see, once again, I don't have any symmetry. I can't flip it over the y-axis and look and get the exact same thing, and I can't rotate it around the origin and get the exact same thing unless I go all the way around. Right? Again, I'm going through this fast because this is review. You know, and you should have completed these, or if you're stuck on a certain problem, you know, you can fast forward or rewind, whatever you need to do. All right, so I'm going to pause now. Okay, so now we're going to do some long division. 2.3 is polynomial division. I'm fine if you do either synthetic or long division. Just do what exactly the problem asks you to on the tests. If it says use synthetic, you must use synthetic. If it says use long, you must use long. Okay? All right, so for this problem, we're going to go ahead and use long division. How many times does x go into 2x cubed? Well, that's 2x squared. And we end up with 2x cubed plus 12x squared. Now keep in mind that we are subtracting here, so that gives me 2x squared plus 20x. X goes into 2x squared 2x times, so that gives me 2x squared plus 12x, still subtracting, gives me 8x plus 48 plus 8, and that gives me 8x plus 48 down here, and subtracting, that gives me 0, which tells me that x plus 6 actually is a factor of 2x cubed plus 14x squared plus 20x plus 48. This, however, the 2x squared plus 2x plus 8 is my final answer, because all I had to do was divide. Anything like that. So that was kind of a nice thing. Okay, so the next problem we're going to do with synthetic division. So on the outside I'm going to put 6. Okay. On the inside, make sure you have your coefficients right. That should be -1, 0, 0, 180, and 0. So let's bring it down. So that's -1, it's -6, it's -36, that's -216, and again -216. Okay, so what do I know? What do I have? I have -x cubed minus 6x squared minus 36x minus 36 minus 216 over x minus 6. Okay, so simple synthetic division. You can write your answer this way. I'm not going to make you write it the weird way the book asked you to write it. It's not really worth it that much. Okay. All right. So next we have use polynomial division to show that x equals 2 is a solution of that. Then factor the remaining polynomial and list all the zeros. All right. Well, to show that 2 is a solution, you're going to put 2 on the outside, and you're going to do 1, 0, -7, and 6. We're going to do our quick polynomial synthetic division. Notice we got a remainder of 0. That proves that 2 is a solution. Okay, so that's one of our zeros. And now our polynomial that we have left over is just x squared plus 2x minus 3. And that's easily factored to x plus 3, x minus 1. So x equals -3, x equals +1. So all of my zeros are x equals 2, x equals -3, and x equals 1. Let's see if I can write those a little bit better. 2, -3, and 1. And again, remember the degree of this polynomial is 3, so I should get 3 zeros. These happen to be 3 rational zeros, which is nice. Won't always turn out that way. All right. Okay, so section 2.5, zeros of the polynomial. Find all the rational zeros of the polynomial. Well, in order to find the rational zeros, remember the little trick that we had. We had all the possible factors of the constant, which in this case is 6. So we have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, divided by all the factors of the leading coefficient, which is just plus or minus 1. So I only have 8 choices here for a possible rational zero. You know, choose what you want. In this case, I'm going to choose -1. mainly because I know it works and it'll go a little bit faster. But if you happen to choose, if you happen to choose one that doesn't work, just try another one. Okay? There's 8 of them. Eventually you'll find one. All right. So my coefficients are 1, 0, -7, and -6. So bring down to 1, it becomes -1. That becomes -1. That's 1, that's -6. That's +6. Hey, I got a 0 for a remainder, so that's a good thing. That means that -1 is one of my zeros. So now I have x squared minus x minus 6. Well, that's easily factorable, the x minus 3, x plus 2. And I get x equals 3, x equals -2. So all the rational zeros happen to be -1, x equals 3, and x equals -2. Notice all 3 of those are amongst your 8 choices. So you had a 3 in 8 chance of finding one of the rational zeros. Now, that doesn't always work that way, but any rational zero will be one of your choices. Okay? So let's go to number 2. Number 2, we've got, we have, again, 6 as our constant, so we've got plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, all over 1, plus or minus. All right, so let's see what we can do. Let's try something different. Let's try 6. So 6, we've got 1, 8, 13, and 6. So we bring down to 1, we have 6. 8 plus 6 is, okay, actually let's do -6, sorry. We're going to do -6. 8 plus -6 is 2. That gives me -12. That gives me 1. Hey, that gives me -6. 0. So now I know that -6 is one of my answers. And then what kind of polynomial do I get? X squared plus 2x plus 1. Well, this is very easy to factor. It's x plus 1 times x plus 1. So that means I have x equals -1, a multiplicity of 2, because it shows up twice. Okay? So our zeros, our rational zeros are -6 with a multiplicity of 1 and -1 with a multiplicity of 2. All right, and now the last one. This one's a little bit trickier, and then you have to understand what you're doing. Okay? So here we go. All the zeros of this function, if you know that one of the zeros is 5 plus 2i. What I have a tendency to do here is, so I say, okay, if one of the zeros is 5 plus 2i, then I know that I have another zero at 5 minus 2i. So I have 5 minus 2i and 5 plus 2i. I have to have those because they are irrational, and all irrational zeros come in pairs. Okay? So, what does that mean? That means that I know that eventually I ended up with x equals 5 plus or minus 2i as an equation. Well, I want to undo this and put it back in and make it into some sort of like something that equals 0. Okay? So let's move the 5 over first. So I'm going to have x minus 5 equals plus or minus 2i. Whenever I have a plus or minus, that tells me in order to get rid of it, I'm going to have to square it, because sometime or another I took a square root to get plus or minus. Because remember, whenever you take a square root, you have the positive root and the negative root. Okay, so if I square this properly, I get x squared minus 10x plus 25 is going to be equal to, now, what is 2i squared? Well, 2 squared is 4, and I squared is -1. So I'm going to have x squared minus 10x plus 25 is equal to negative 4. Move that over. X squared minus 10x plus 29 is equal to 0. So here is a factor, x squared plus 10 minus 10x plus 29. I know that this is a factor of that big long polynomial. So what I'm going to do is say, okay, if this is a factor of that polynomial, if I divide that into the polynomial, I should get my other factor, and if I find my other factor, then I can find my other 0. Remember, the degree is 3, I should have 3 zeros. I already know 2 of them. Let's find our third one. So since this is a factor, I'm going to do x squared minus 10x plus 29. I'm going to divide it into x cubed minus 7x squared minus x plus 87. All right, so that's going to give me an x. So that's going to give me x squared minus 10x plus 29, sorry, x cubed minus 10x squared plus 29x. All right, again, remember we're subtracting these. So I've got negative 7 minus negative 10, which ends up being 3x squared. Negative 1 minus 29, so it's minus 30x. And then I bring down my 87. So x squared goes into 3x squared 3 times. So I end up with 3x squared minus 30x plus 87. If I subtract that, I end up with 0, as I should. So my last factor is x plus 3. So my last 0 is x equals negative 3. So my 3 zeros are x equals negative 3, and my 2 up at the top, 5 minus 2i and 5 plus 2i. Again, guys, watch it again if you need to. All right, you can stop, you can rewind, whatever the case may be. All right, rational functions. I'm only going to do problem number 1 because problem number 2 there was some difficulty with, and I'm going to go back over that again tomorrow. So I'm going to do problem number 1 on this one. Okay. So for this function, we need to do everything. The slant asymptotes or the horizontal asymptotes, any holes, any vertical asymptotes, zeros of multiplicity, and the y-intercept, and then graph it. Okay. So the function is negative 1 over x minus 2 squared. Vertical asymptotes. I have a x minus 2 equals 0. So x equals 2 is a vertical asymptote. Excuse me, is a vertical asymptote. The degree of the top is less than the degree of the bottom, so I have a horizontal asymptote at y equals 0. There's no factors to cancel out, so there's no holes. Okay. Setting the numerator equal to 0 doesn't make any sense, so I don't have any zeros. Okay. The y-intercept, plug in 0 for x, I get negative 1/4. So I get y-intercept of 0 comma negative 1/4. All right. Now we graph it. All right, so I've got my asymptote here at x equals 2. Please write the equation. I have another asymptote on my y-axis, so I have y equals 0. Okay, I have the point 0 comma negative 1/4. So there we go. So let's find another point. So let's choose 1. If I plug in 1, I get negative 1. Okay. So my graph is going to do something like this. Now let's choose points on the other side. Choose 3. If I plug in 3, I get negative 1 again. If I plug in 4, I get negative 1/4. You can do the math to prove it. And there's your graph. Okay. the reason that we have a mirror effect here is because our vertical asymptote of x equal 2 actually appears 2 times because of the square up here. All right, so because we have the square and it appears 2 times, it kind of ends up being a reflection of itself over that asymptote. Okay. Okay, last but not least, solve the inequality and graph the solution on the real number line. Okay, so we have x squared plus x is less than 6. So we got x squared plus x minus 6 is less than 0. Because again, we always want to compare it to 0. Now we're going to factor it to find our 2 key points. So x plus 3, x minus 2. So our 2 key numbers are x equals negative 3 and x equals 2. All right, so our number line, we've got negative 3, we've got 2. I have an inequality, so I'm definitely going to have open circles here. And now I just have to test it. So let's pick a number to the left of negative 3, like negative 4. Negative 4 plus 3, that's negative, and a negative. A negative times a negative is a positive. I want less than 0, so this is a no. 0 is in here, so I've got a positive times a negative, that's a negative, so that's a yes, so I'm definitely going to be shading in here. Now greater than 2, let's try 3. That's a positive, that's a positive. Positive times a positive is a positive, so that's a no. So the only shading is between negative 3 and positive 2, and to put that in one of the two forms, negative 3, comma 2. Right. Let's look at number 2. I've got 3x minus 5 over x minus 5 has to be greater than or equal to 0. Now, again, guys, math jail takes precedence here. So we can't have it equal to 5, even though 5 is one of our key points. We can't have it equal to 5 because if I do 5 minus 5, I end up with 0 in the denominator. Okay, so my key points are going to be x minus 5 equals 0. So that's going to be x equals 5. But it can't be equal to 5, so I'm going to have an open circle. And then I have 3x minus 5 is equal to 0. So 3x equals 5, x equals 5/3. Now there's nothing wrong with having a 0 in the numerator, so that's going to be a closed circle. Okay, so here's our number line again. We've got negative 5. We've got 5/3. Again, open circle and negative. Oh, sorry. Let me redo that. Okay, so I've got 5 over 3 and 5. It's going to be a closed circle and 5/3. And it's going to be an open circle and 5. And we have 3 areas to check. Well, what's something that's less than 5/3? 0. Okay, let's do 0. 0, so that's going to be a negative divided by a negative, which is a positive. Is that greater than 0? Yes. So we are going to definitely shade in this part of the line. Now, what's between 5/3 and 5? Well, let's try 2. We've got a positive up top and a negative in the bottom, so that's going to be a negative, so this is a no. Okay, and then what about 5? Well, we can't do 5, so let's do 6. So we've got a positive divided by a positive, which is a positive, so this is a yes, so we're going to fill in that. And then how do we write this in interval notation? Well, negative infinity to 5/3, and we are including 5/3, union of 5 to infinity. Right, that's up number 2. And then number 3 is actually really, really easy. Okay? The hard part is figuring out what the question's asking you. The question's saying, according to the graph, where is the function less than 0? Well, if you look at the graph that's been given to you, everywhere between negative 4, 0 and 3, 0, except for the point 0, 0, is less than 0. So on the number line, let's put our key points on there, our 3 zeros. So we've got negative 4, we've got 0, and we've got 3. Now, at -4, it is equal to 0, but we want less than 0, so it's an open circle. Same thing at 0, and same thing at 3. It's equal to 0 at all 3 places. Now, according to the graph, it is definitely negative, or less than 0, between -4 and 0, and also between 0 and 3. Okay? So this is the reason this was on here, is to show you that not every single function does that alternating thing that we talked about in class. A lot of them do, the vast majority of them do, but not all of them do. So this is a perfectly good function that you could figure out the equation for eventually. You actually have the skills to do that, but I'm not going to ask you to. And this is the graph, okay? And then how would you write this? If I asked you to, how would you write this in interval notation? Well, it would be -4 to 0, 0 to 3. And that's it. All right, guys, I hope this helps.